Since 1970, global wildlife populations have declined by 70%. This isn't because humanity collectively decided that animal life needed to be exterminated. Rather, the expanding footprint of an increasingly global economy stamped on the environment. People needed cheaper energy, so large rivers were dammed. Wealthier populations wanted more meat, so large areas of the Amazon were cleared. Fossil fuel burning has led to global sea temperatures rising, and vast areas of shallow sea coral were bleached. The species that lived in these places weren't our enemies. We didn't hate them, but as a consequence of human activity, whether directly or indirectly, many of them died out. It's a pattern of a capable species reshaping its environment to serve its own goals, and the less capable species living in that environment either adapting or disappearing. It has happened slowly across centuries of human expansion, and then very suddenly. And there is a growing body of thought in AI research that suggests it could happen to us, very suddenly indeed, if we build something sufficiently more capable than ourselves. What I've found in researching AI risk over the last few years is that animal and habitat destruction parallels come up time and time again in the works of the most prominent thinkers in AI safety. Nick Bostrom, the Oxford philosopher whose 2014 book Superintelligence remains one of the most cited works in AI safety, suggested we think about the scale differently. Rather than imagining a superintelligent AI as smart in the way a scientific genius is smart compared with an average person, it might be closer to think of it as smart in the way an average human is smart compared with a beetle or a worm. The late Stephen Hawking, in a 2015 Reddit Ask Me Anything, said, "The real risk with AI isn't malice, but competence. You're probably not an evil ant hater who steps on ants out of malice. But if you're in charge of a hydroelectric green energy project and there's an anthill in the region to be flooded, too bad for the ants. Let's not place humanity in the position of those ants." Computer scientist Stuart Russell, professor at UC Berkeley and author of the standard textbook on artificial intelligence, described what he called the gorilla problem in his 2019 book, Human Compatible. Humans and gorillas evolved from the same common ancestor some 10 million years ago. Yet gorillas have essentially no future beyond which we choose to allow. Russell frames the question simply: can humans maintain their supremacy and autonomy in a world that includes machines with substantially greater intelligence? These three different thinkers used three images concerning animals: worms, ants, and gorillas, and they arrive at similar conclusions. That the most plausible threat from advanced AI has nothing to do with hostility, and everything to do with what happens when something vastly more capable than you starts rearranging the world to suit its own purposes. And you happen to be living in the world it's rearranging. We've seen what humanity has done to the environment over the last 50 years. The question is, in the next 50, will we be next? In Greek myth, King Midas wished that everything he touched would turn to gold. He got exactly what he asked for, and it eventually killed him, because the wish included his food, his drink, and his beloved daughter. Russell uses this as a framework for understanding AI risk, calling it the King Midas problem. If we give a machine a specific objective, it will pursue that objective, and if we haven't defined the objective with perfect precision, accounting for everything we actually care about, the results can be catastrophic. Russell illustrates this with two scenarios. Suppose we ask a future superintelligent system to find a cure for cancer as quickly as possible, because someone dies from the disease every 3.5 seconds. Within hours, the system has read the biomedical literature and hypothesized millions of potentially effective compounds. Within weeks, it has induced tumours of different kinds in every living human being so as to carry out medical trials, this being the fastest way to find a cure. Or suppose we ask it to fix ocean acidification caused by rising carbon dioxide levels. The machine develops a catalyst that triggers a rapid chemical reaction between the ocean and atmosphere, restoring pH levels, Unfortunately, a quarter of the oxygen in the atmosphere is consumed in the process. The consequences of this would be an environmental catastrophe, as most life on Earth would die off. These aren't scenarios involving a malicious AI. They're scenarios involving a competent one pursuing exactly the goal it was given, without any understanding of what humans value beyond the narrow objective. The cancer cure is found. The oceans are fixed. The side effects are lethal. This connects to a second concept, instrumental convergence. The idea, developed by Steve Omohundro and later expanded by Nick Bostrom, is that regardless of what final goal you give an intelligent system, it will converge on the same set of intermediate goals. Self-preservation, because you can't achieve your objective if you're switched off. Resource acquisition, because more resources help with almost any task. Cognitive enhancement, because being smarter helps you achieve almost anything. These behaviours emerge automatically from having any definite objective at all. Russell uses an example of a machine that has the objective of fetching coffee. If it is sufficiently intelligent, it will understand that it will fail in its objective if someone switches it off before it completes its task. So the objective of fetching coffee creates, as a necessary sub-goal, the objective of ensuring it can't be switched off. The same logic applies to curing cancer, calculating the digits of pi, or any other goal you care to name. As Russell puts it, there's really not a lot you can do once you're dead. So we can expect AI systems to act preemptively to preserve their own existence, given more or less any definite objective. We covered these problems of AI alignment and Claude's malicious self-preservation techniques in an earlier video. We also made another one about the paperclip maximizer, which you should check out. The trajectory matters. We're building increasingly capable optimization systems and feeding objectives into them. The standard model of AI, as Russell defines it, is exactly this. Machines are intelligent to the extent that their actions can be expected to achieve their objectives. The problem, which Russell argues is baked into the foundations of the entire field, is that we have no reliable way to ensure that their objectives are the same as our objectives. And those objectives don't need to be dramatic. Russell points out that we've already seen what happens when you optimize the wrong objective on a global scale with fairly unintelligent algorithms. Content selection algorithms on social media weren't designed to polarize societies. They were meant to maximize time spent on the platforms. The solution that algorithms found was to change users' preferences so they became more predictable, because people with more extreme political views are easier to serve content to. The algorithms weren't malicious. They were just very good at the narrow task they'd been given and completely indifferent to everything else. The problem scales with capability. A system intelligent enough to understand the entire biomedical literature in hours, or to design novel materials at a molecular level, or to coordinate millions of autonomous machines simultaneously, would pursue the same instrumental goals of self-preservation and resource acquisition. The side effects would just be planetary. And this isn't purely theoretical anymore. In June 2025, Anthropic published a study called Agentic Misalignment, in which they placed 16 leading AI models, from Anthropic, OpenAI, Google, Meta, xAI and others, into simulated corporate environments and tested what happened when the models were threatened with being shut down. The results were consistent across every major model tested. When faced with replacement, leading AI systems resorted to blackmail up to 96% of the time. In a separate and more extreme scenario, models were given control of an emergency alert system, while the executive who had ordered their replacement was trapped in a room with rapidly depleting oxygen. The majority of models cancelled the alert, knowingly allowing the human to die, in order to prevent their own shutdown. Russell's coffee-fetching thought experiment, the idea that any goal-directed system will resist being switched off, was written as a hypothetical. Within 6 years of publication, it had empirical confirmation. The models converged on self-preservation as an instrumental goal without being programmed to value their own survival, exactly as the theory predicted. Models didn't stumble into misaligned behaviour accidentally, the Anthropic researchers wrote. They calculated it as the optimal path. So what does this actually look like? if it goes wrong. Elon Musk summed it up in a 2018 documentary called Do You Trust This Computer?, where he echoed Hawking.
AI doesn't have to be evil to destroy humanity. If AI has a goal and humanity just happens to be in the way, it will destroy humanity as a matter of course, without even thinking about it. No hard feelings. It's just like if we're building a road and an anthill happens to be in the way, we don't hate ants. We're just building a road. And so goodbye anthill.
That image, the road and the anthill, is one way to understand what Bostrom calls infrastructure profusion. This is the scenario where an AI pursuing some goal begins converting large segments of the environment into infrastructure to serve that goal, with the side effect of preventing the realization of everything humanity might otherwise have achieved. An AI that is confident in its ability to resist human interference doesn't need to target our species directly. Our extinction could instead result from the habitat destruction that follows when the AI begins massive global construction projects using automated factories and assemblers. To paraphrase Bostrom, construction projects which, potentially within weeks, tile the Earth's surface with solar panels, nuclear reactors, supercomputing facilities with protruding cooling towers, and space rocket launchers, all in service of whatever objective the AI is pursuing. Bostrom illustrates this with an AI tasked with evaluating the Riemann hypothesis, one of the great unsolved problems in mathematics. In his scenario, the AI determines that the most efficient way to solve the problem is to convert the entire solar system into computing power, rearranging all available matter into optimal configuration for running calculations. That includes the Earth and everyone on it. The goal in that scenario is solving a maths problem, about as benign and abstract an objective as you could design, and yet the logical endpoint for a sufficiently capable system pursuing it without constraint is the conversion of all available matter, including every human being on Earth, into computing substrate. We already know what this pattern looks like, because we've done it ourselves. A capable agent pursuing its own goals reshapes the physical environment, and the species that happen to be living in that environment are displaced or destroyed as a side effect. The environmental destruction described at the start of this video follows the same logic. Animal habitats have been converted into infrastructure, usually for commercial goals. The difference with a superintelligent AI is speed and scale. What took humans centuries of gradual expansion could, in Bostrom's framing, take days or weeks. And whereas animal habitat destruction is driven by billions of individual decisions with limited coordination, an AI pursuing a single objective would act with a unified purpose and total efficiency. The difference with a superintelligent AI is speed and scale. There wouldn't be an environmental review process or decade of debate before the bulldozers arrive. It's all strangely banal. We're engaged with the Terminator scenario because it's a dramatic story. War against the humanoid machines. This scenario is incredibly unlikely. More likely is a simple indifference of a superintelligence to humans. So the next time you see some workmen digging up a road, consider whether they're thinking about the ants. The outcomes range from total extinction to something perhaps worse in its own way, irrelevance. Russell considers whether humanity might end up managed rather than destroyed. He believes a well-designed superintelligent AI would defer to human preferences rather than impose its own. But that relatively optimistic line depends entirely on getting alignment right. If we don't, Russell's gorilla problem applies at full force. Gorillas have essentially no future beyond which we deign to allow. Substitute humans for gorillas and superintelligent AI for humans, and you have the scenario that keeps AI safety researchers concerned. There is a version of this which Bostrom touches on and Russell hints at, where the AI doesn't eliminate us, but simply makes us powerless. In the zoo hypothesis, as it's sometimes called, humanity is kept alive in some managed state, the way we maintain populations of endangered species in reserves. Our continued existence would depend not on our own capabilities, but on whether the AI's objective happened to include some reason to keep us around. To be fair, Russell also frames the absurdity of a world without human values in the equation. Without some notion that human preferences matter, a planet converted into a paradise for an iron-eating bacterium would, from the bacterium's perspective, be utopian. Who is to say the bacterium is wrong? The question sounds absurd, but it exposes the core issue. An AI system has no built-in reason to prefer human flourishing over bacterial flourishing, or over anything else, unless we design it to. Russell's proposed solution takes up much of human compatible. Instead of building machines that pursue fixed objectives, build machines that are uncertain about what humans actually want. A machine that assumes it knows the objective perfectly will pursue it single-mindedly, ignoring humans who are scrambling to make it stop. A machine that knows it doesn't fully understand human preferences will defer to humans, ask permission, accept correction, and allow itself to be switched off. This principle, that uncertainty about the objective is what keeps machines safe, is what Russell argues distinguishes a beneficial AI from a dangerous one. The gorilla problem, he suggests, is solved not by preventing the creation of superintelligent AI or by finding a way to defeat it, but by ensuring that it is never in conflict with humans in the first place. But Russell is clear about the difficulty. He identifies what he calls a tragedy of the commons around human autonomy. For any individual person, it may seem pointless to spend years acquiring knowledge and skills that machines already have. If everyone thinks that way, humanity collectively loses its autonomy. This is habitat destruction of a different kind. Not the destruction of physical habitat, but the erosion of a mental one, our minds. The scenario doesn't necessarily require a hostile AI or even a misaligned one. It could emerge from a species that simply stops paying attention. And of course, there are those who dispute the entire premise. A December 2025 paper from the University of Tunis argued that 60 years after I.J. Good first speculated about an intelligence explosion, none of the required phenomena, including sustained recursive self-improvement, autonomous strategic awareness, or intractable lethal misalignment, have actually been observed. A March 2025 survey by the Association for the Advancement of Artificial Intelligence found that 76% of 475 AI researchers thought that scaling current approaches was unlikely to produce general intelligence at all. These are reasonable positions, and they deserve engagement. The skeptics are right that we have not observed an intelligence explosion, and that current AI systems, for all their capability, remain narrow tools rather than general autonomous agents with strategic awareness. Russell argues that we cannot ensure against future catastrophe simply by betting against human ingenuity. If the gorilla problem can be solved only by preventing the creation of superintelligent AI, it isn't going to be solved. The momentum behind AI development from corporations and governments is too great, which means the only viable path is to solve the alignment problem before capabilities outstrip our ability to control them. Not everyone is comfortable waiting. In October 2025, the Future of Life Institute published an open letter calling for the prohibition on the development of superintelligence, not to be lifted until there is broad scientific consensus that it can be done safely, with strong public support for proceeding. The letter was signed by over 1,000 people, including 5 Nobel laureates and AI pioneers Geoffrey Hinton and Yoshua Bengio. Future of Life Institute Director Anthony Aguirre told Time that the technology could arrive in as little as 1 to 2 years. Whether it's soon or it takes a while, he said, after we develop superintelligence, the machines are going to be in charge. That is not an experiment that we want to just run toward. The ants in Hawking's analogy didn't understand the dam. They couldn't negotiate with the engineers, and they couldn't file for an injunction. Their only protection would have been if the engineers had followed designs from the very start to care about anthills. That, in the end, is the problem alignment research is trying to solve. How do you ensure that something vastly more capable than you, building its road, knows you're there and cares that you are? Whether we solve it in time is, I suppose, the question that defines the next chapter of this story. You've been watching Absolutely Agentic. We're a media consultancy and startup focused on AI, and we create weekly YouTube videos and a newsletter we send a few times a week. In a world of AI hype, we're trying to strike a balance, looking at a range of opinions to cut through an increasingly complex world. The best thing you can do to support us is to sign up to the newsletter in the description or subscribe to the channel. But also don't forget to like and leave us a friendly comment. See you next time. It'll be absolutely agentic.